Hello and welcome to Physics Problems One by One. So here is a problem. As always, read it, maybe once, maybe twice, and then pause the video and try to solve it yourself. Today's problem will start with a picture. We have a free-falling body that starts with V0. And because it's free fall, we know that its acceleration is g. And it covers distance, and this distance is, let's say, h, and h stands for height. It's common. And so this is a body, and it hits the bottom, and it jumps back. And it's absolutely elastic hit. Let's say it's not a rock, because rock is not elastic, but let's say it's a ball. So it's basketball. So we drop it down from the height h, and we want to give it initial speed v0. And the question is, after it will be deflected up, it should, I will not draw here, I will draw to a side, so not to make it crowded. It will go up, and it will go double the height, 2h. So this is 2h, and this is h. And the question is v0, right? That's what they tell us. They don't even tell us what h is. All they tell that it is 2. But that's the picture. So basically, we start from here and we go here, right? And of course, we can say that the speed here and this moment, let's put it v at the ground, vg. So we have v0 that they want to ask us, that unknown, but let's imagine we know it. H, height, yes, and we have this and that. Well, of course, we want to write a formula. Pause, hint, correct. The formula is for the distance, and the formula is h equal, in the bottom, two accelerations, 2a, which is 2g, and v ground squared minus v0 squared. And let's put it v ground. Okay. And that's the first equation. And now, when we hit it, we reverse our speed. That means elastic collision. The speed just changes direction. No loss of energy. And the speed goes from directed down to directed up. And then we have the second part of it. And the second part, we start from here, we go here, we start with initial velocity vg, and we end with 0 speed, right? So let's apply the same formula. Only this way it would be 2h. Final speed here for this formula would be 0. Z squared, right? 0 squared minus initial speed would be vg, vg squared, divided over same 2a, and 2a is 2g. And those are two formulas, right? And all that's required is simplification, and let's do it. Let's send it here, so it's no fractions. 2gh equal vg squared minus v0 squared. This is this. And then here, oh, this is a mistake here. It would be negative, but it cannot be negative. 2h is a positive number. If it would be negative here, it would be a mistake. Would be minus. But of course, I forgot to put minus here, because when I go from here to here, it is distance. This is final, which is 0, which is initial, which is this way, right? And then it is g, but g is directed against, so it's deceleration. So this would be the formula for the first one, and this would be the formula for this one, and it would be minus 4gh, 2 by 2 gh minus equals minus v0 squared, right? And what I wrote wrong here, minus vg squared, right? I'm rewriting this equation here, and this equation, and obviously this is this equation. So once again, minus 2g, minus 2 by minus 4, gh equals minus vg squared. Okay, so let's find vg squared from one side and put it into another. For example, here, let's leave it alone. 2gh plus v0 squared equal v ground squared. This is this equation, and here we reverse it and we will write vg squared equals 4gh. And now all I have to do, I have to say that this equals to this. So let's continue. 2gh plus v0 squared, right, equals 4gh. And they're asking us about v0, so let's isolate it. v0 squared equal 2gh, and v0 equal 2gh. So yeah, h of course is given, but it's important that this is double. So basically yes, h is known and given, but we know is not known. And so we find v0 square root of 2gh, and we put whatever. For example, if h is 10 meters, as they say, square root would be v0 square root of 20, 2g is 20 roughly, h is 10, so it would be square root of 200, which is roughly 14. So 14 meters per second. So if we're throwing it from 10 meters, we have to give it 14 meters, quite a bit of speed to gain double of. If we're throwing, for example, with h equal 1, it would be square root of 20, which would be significantly less, it would be approximately 4.5 meters per second. But basically that's answers this question, solves this problem. For the future problem, subscribe, bell, like, comment, question your problem, and I see you next time.